So to perform calculations with KSP, you need to know what the solubility is. So this is a molar concentration of ions in water. So if you write the equation for the solubility of cuprous or copper 1 bromide, you're going to see this as your equation. So then your KSP is going to be this. So if we look at the molarity, we're going to get a 1-to-1 mole ratio. So we are going to see that we are going to get 2.00 times 10 to the minus 4th. Oh, sorry, 10. And you'll find there were very few sig figs for these, so they're a little bit tough to measure, which is really important that you look at the reference. So if you're using tables other than your textbook references when you do problems, you may find that the values are slightly different. So if we square this one, this would be 4 times 10 to the negative 8th. Again, just like other Ks, there are no units on these. All right, my next one, I'm going to do the equation for bismuth 3 sulfide. And we had this one on the front. So I'm going to get bismuth plus 3 plus sulfur minus 2. Again, balancing is important. So 2 bismuths, 3 sulfides. So my KSP value is going to be Bi plus 3 squared and the sulfide ion concentration cubed. Now here my molar stoichiometry. So if this is the concentration of the entire compound, I have to do 2 times the 1.0 times 10 to the negative 15th. And for this one I have to do 3 times 1.0 times 10 to the negative 15th. So this would be 2.0 times 10 to the negative 15th, and this is 3.0 times 10 to the negative 15th. So I'm going to substitute those into my formula. You need to match your ions carefully. So this is going to be squared, and then the 3.0 times 10 to the negative 15th is going to be cubed. So when you calculate all of that in your calculator, you're going to get 1.1 times 10 to the negative 73. And again, if you want to see how that calculates, 2 EE 15 negative, you can use your squared button for that one, and then times 3. I'm going to use my y to the x. Your calculator may have the caret key, so you may see this button. Third. Alright, I don't know what I did there, but 2 EE 15 negative squared times 3 EE 15 negative y to the x cubed. And you'll see I at 1.01, but I'm doing 2 sig figs, so 1.1 times 10 to the negative 73rd. For question 3, we have the KSP value for copper 2 iodate. So I'm going to write that formula and equation. And its KSP value is, our equation, is the concentration of Cu plus 2 times the concentration of iodate squared. So this is going to be like any other ice type table. So it doesn't really matter what this is because it doesn't show up in the equilibrium expression. So we're going to assume that we're starting with all solids, so there's none of this. So just like any other equilibrium, we're going to add some amount because it's going to shift this direction. And then this is going to be plus 2x. So this will be x, and this will be 2x, and then I'm going to substitute in to my equation. So the 1.4 times 10 to the minus 7 equals x times 2x squared. So this is going to give me 1.4 times 10 to the negative 7th equals 4x cubed. So on my calculator, I'm going to do 1.4 EE7 negative. Again, probably most of your calculators, you have to put the negative 7 in first. Divided by 4. And I'm going to convert that to scientific notation. And that's going to give me 3.5 times 10 to the negative 8th equals x cubed. And if you've ever noticed this button, so you're going to have to do the second function to get to that and do the cube root of that. And that gives me 3.3 times 10 to the negative 3rd. And this one, because its concentration, will be m or moles per liter. So that will be the solubility of that substance. Now, it's not the concentration of the ions. If we want to go back and do concentrations, concentration when it dissolves is at equilibrium is going to be 3.3 times 10 to the negative 3rd for the copper 2, and then it will be 6.6 times 10 to the negative 3rd for the iodate. So again, this is from the perspective of the compound. I'm going to finish up the notes for the bottom of page 1 when I do the video for page 2, because I think it's going to make more sense for you. So there are some sample problems for you to do. So you can work on that problem set.